In this lesson of graphing rational functions, we're going to talk about the key characteristics of the rational functions. So some of these characteristics we've discussed in other functions, but just to recap, we're going to look at positive and negative intervals, and that's the sections of the function that are above or below the x-axis. So that means the y values are positive or the y values are negative. We're also going to look at those domain intervals of increase and decrease, looking to see the parts of the function that are rising or getting larger, and those that are falling or getting smaller, going lower below the y-axis. And then the last one is your end behavior, and that's to look to see the y value that the function approaches on each side, on the very far sides of the graph. So those positive and negative intervals of the domain, in order to determine them for rational functions, we need to use the x-intercept and the vertical asymptote of the function. And remember, those positive intervals are where the function is above the x-axis. So the y values, if you look at a table, wherever your x's are, your y's would be positive. And for the negative intervals, that's where the function is below the x-axis. So again, those y values of the function would be negative. Our first example stating the positive and negative intervals of the function. So we first want to determine the x-intercept. In this graph, it crosses the x-axis at -3, so that's our x-intercept. Next, determine your vertical asymptote, and we see our vertical asymptote at x equaling -4. Now we're going to look at the sections of the graph across the entire domain. So we're going all the way from -infinity to the vertical asymptote the x-intercept, and an x-intercept all the way out to positive infinity. So we're going all the way across the domain. So to determine the positive intervals, we're looking where it's above the x-axis. So our graph is only above the x-axis between the vertical asymptote and the x-intercept, from -4 to -3. That's where it's positive. And then all of the other portions of the graph, from -infinity to -4, and then again from -3, the x-intercept, out to positive infinity, is where the function is negative. Okay, so again, where is it above the x-axis and where is it below the x-axis? Okay, good start. Next topic is the domain intervals of increase and decrease. In order to determine those sections of the function that are increasing or getting larger, going upwards, and decreasing, which are going downwards, we're going to have to use the domain of the function and the vertical asymptote. Okay, so I've got to know that vertical asymptote that splits the domain into those groups. So the increasing intervals are where the sections are going to rise or where they're going to be going upwards. Decreasing intervals are where the sections of the graph that are going to fall or going to be going downwards. So our example for this one is to state those increasing and decreasing intervals of the function. So again, we've got to determine the vertical asymptote. This one has a vertical asymptote at x equaling -4, and then state the domain from -infinity to -4, union -4 to infinity. Now as we look across the entire domain, we're going all the way from the left to the right. We want to see, is the function increasing or decreasing? So as I go from -infinity to -4, it's not increasing. As I go from -4 to infinity, it's not increasing again. So there's no sections of increase for this function. However, the sections of decrease are from -infinity to -4, and again from -4 to positive infinity. So basically that domain is going to be used in order to state the interval of increase or decrease. And the last topic for this particular lesson is the end behavior of rational functions, which are in transformational form. So we're going to use the value of the horizontal asymptote of the function y equals k in order to determine what y value the function approaches on the very, very far left as x approaches -infinity, and on the very far right as x approaches positive infinity. And our notation is red. As x approaches -infinity to the left, f of x, or the y values, approach k, whatever the value of that horizontal asymptote is. And the right side, as x approaches positive infinity, f of x, or the y values, again approach k, the value of that horizontal asymptote. So for this example, we're going to state the end behavior of the graphed rational function. All we need to do is to determine the horizontal asymptote. And we can see that the horizontal asymptote is occurring at y equaling -1. Therefore, on the left, as x approaches negative infinity to the left, the y values f of x approaches -1, that value of the horizontal asymptote. And on the right side, as x approaches positive infinity all the way to the right, again, f of x approaches the value of the horizontal asymptote, f of x approaches -1. All right, now we're going to go through 3 examples of positive and negative intervals, then increase and decrease, and lastly, end behavior. So example 1, state the positive and negative intervals of the function. Remember, for this, we need to determine the x-intercept. Where does the graph cross the x-axis? In this case, at x equaling -3. We also need to know the vertical asymptote. This graph has a vertical asymptote at x equaling +1. Now that we know those 2 things, we're going to go across from negative infinity to -3, -3 to 1, and 1 to infinity, looking at that entire domain for the function. So as we go from left to right, we notice that the entire function is decreasing, but it's asking, where is it positive? Where is it above the x-axis? Well, that first section from negative infinity to -3 is above the x-axis. And the other part is on the right-hand side of the vertical asymptote, from 1 out to positive infinity. Those 2 sections, negative infinity to -3, union 1 to infinity, are the positive sections of this function. Therefore, between the x-intercept and the vertical asymptote, between -3 and +1, that's where the function is negative and underneath the x-axis. Great job, guys. All right, number 2, again, determine positive and negative intervals. So we need to determine our x-intercept. We're going to estimate this one to be at about 2.5. And then our vertical asymptote is at x equaling 3. So we're going above the x-axis. That only occurs in this little section between the x-intercept and the vertical asymptote from 2.5 to 3. That's our positive interval. Every other part of the function is negative. It's below the x-axis from negative infinity to 2.5, and then again from 3 out to positive infinity. So negative infinity to 2.5, union 3 to positive infinity. Number 3, state positive and negative intervals of your function. Determine your x-intercept at x equaling -5. Determine your vertical asymptote at x equaling -1. Determine where the function is above the x-axis. The section between -5 and -1 is where your function is positive. All other portions of the function are negative, from negative infinity to -5, and from -1 to positive infinity. All right, our next 3 examples are going to be looking at those domain intervals of increase and decrease. Okay, so we need to see, where's the function going up, where's it going down. So we need to know the vertical asymptote value, which is x equaling 1, and then state the domain. We're going to use that domain to give us the increase and decrease intervals. As we look at this example, as we travel from negative infinity to positive infinity, the left-hand side of the function is going down, and the right-hand side of the function is also going down. Therefore, it does not increase. There are no sections of increase. The entire function decreases. So the domain, negative infinity to 1, union 1 to infinity, is the intervals of decrease. Number 5, again, domain intervals of increase and decrease. First, determine your vertical asymptote at x equaling 3. Then state your domain, negative infinity to 3, union 3 to infinity. And now determine, as we move from left to right, does the function increase or does the function decrease? The first section from negative infinity to 3 increases, and then from 3 to infinity, the function still decreases. So this function increases across the entire domain and has no section of decrease. And last one for domain intervals of increase and decrease. Again, start with your vertical asymptote at x equaling -1. Use that to state the domain. Negative infinity to -1, union -1 to infinity. Look to see what the function does. The far left is increasing towards the vertical asymptote, and from the vertical asymptote to the far right, it's also increasing. So again, the entire domain, negative infinity to -1, union -1 to infinity, the function increases. There is no section, or there are no sections, of decrease. And our last examples stating the end behavior of the given function. In order to determine the end behavior, we need to know the horizontal asymptote. So that is the line that is laying across, cutting the range of the function. So our horizontal asymptote is at y equals +1. And as we look to the far left side of the graph, as x approaches -infinity, the y values approach 1. As I look to the far right side of the graph, as x approaches infinity, f of x approaches 1. The horizontal asymptote for our next example is occurring at y equaling -2. So determine the end behavior of this given function. As x approaches -infinity to the left, the y values f of x approaches -2. As x approaches +infinity to the right, as the graph goes all the way to the right, again, the y values, or f of x, approaches the horizontal asymptote at -2. And our last example, again, state the end behavior of the function. So determine where is the horizontal asymptote. Our horizontal asymptote has a value of y equaling -1. The left side, as x approaches -infinity, f of x approaches the horizontal asymptote -1. And on the right side, as x approaches +infinity, f of x approaches -1. Great job with this lesson. Make sure you guys are practicing and let us know if you have any questions.